Welcome to What's Up Over Edmonton for the month of December. My name's Jeff Robertson, and I am a member of the RASC Edmonton Center. As we can see, we've got Santa and a Christmas tree in front of the QEP. Our original plan was to hold these sessions live in the QEP, but I don't know if we're ever going to do that. I call this What's Up Over Edmonton because the skies over Edmonton are different than what is normally presented in a lot of astronomy publications like Sky News and Astronomy Magazine. For example, in Toronto, this is what the sky looks like at 11 o'clock on July the 5th. The constellation Scorpio is fully above the horizon. You can see the whole thing. But in Edmonton, we never see the whole constellation here at 53 degrees north latitude. We only see its head. Most of the information I use comes out of the Observer's Handbook, which is a publication put out by the RASC every year. The 2023 handbook arrived at my door last month. It's sent out to all members of the RASC or to anyone who happens to order one from the bookstore. So what do we got in December? We've got long nights, we've got ugly sweaters, and we've got bad music on the radio. And I say that because although everyone loves Christmas songs, some of them are really just bad music. I really hate Feliz Navidad because there's only 4 lines in the song and it goes on for over 3 minutes. Although I did buy a CD last year called from William Shatner called Shatner Claus, and he put a new spin on it. So I appreciate Feliz Navidad a little bit better now that I've heard how Bill does it. So what do we got? We got Mars at opposition on December the 7th with a bonus occultation. We've got the Geminid meteor shower on the nights of the 13th and 14th. We've got the Ursid meteor shower on the 22nd. So yes, we have 2 meteor showers this month. For the Geminids, the moon is going to compete with the shower. The Ursids have no moon to speak of. And we have the winter solstice on December 21st, the official beginning of winter. And the nights start getting a little bit shorter and the days start getting a little longer. So this is the planetarium portion of the session. And as usual, I have pre-recorded it and I will start it now. Let's start off by looking at the sunrise and sunset times for the month of December. On December 1st, the sun will rise at 8:27 a.m. It will set at 4:18 p.m. and astronomical twilight ends, that is, night truly begins, at 6:26 p.m. On the 31st of December, the sun rises at 8:50 a.m. It sets at 4:23 p.m. and night begins at 6:39 p.m. That's all Mountain Standard Time. Let's look at the planets for the month of December, and we have all 8 of the planets in the evening sky, although you have to get out right after sunset to see 2 of them. Mercury reaches its greatest eastern elongation, that is, when it is farthest from the sun in the evening sky on the 21st, the day of the winter solstice. And Venus is starting to make an appearance in the evening sky after being in the morning sky for the past many months. Again, this is all right after sunset. The time I've set here is 4:45. On Christmas Day, Mercury and Venus are joined by a 3-day-old moon, which would show a very nice crescent. The appearance of Venus in the evening sky, and also in the morning sky, follows 5 different paths, and these paths repeat themselves every 8 years. The path of Venus in the evening sky for this appearance is this. If you'll recall, when it was last in the evening sky, it hung fairly low to the horizon and didn't really get that high. But this time, Venus will get fairly high in the sky later on in the spring. Around May, it'll be quite high in the sky and set a few hours after the sun. Advancing the time to 7 o'clock, when the sky is well and dark. The next planet in line would be Saturn with its marvelous ring system. December is pretty much the last good chance to observe Saturn, even with a small telescope. At the beginning of the month, it's setting at 9:53. By the end of the month, it's setting at 8:10. So into January, as it gets dark and the days are starting to get a bit longer, Saturn is going to be very near the horizon in all the muck and the guck of our atmosphere, and will not present a very good picture. The scene will just be bad. Moving along to Neptune. Neptune is still well placed in the sky, and with even a small telescope will show a blue marble disk, and of course a large telescope will just show it that much better. In binoculars, you can see it. You aren't going to see much other than just a blue disk. And moving along, we come to Jupiter. And in this view, which happens to be at 7 o'clock on the 15th of December, we can see all four of the Galilean moons, Io on one side, Ganymede, Europa, and Callisto on the other. And at 7 o'clock, Ganymede's shadow happens to be crossing the disk of Jupiter. So if you have a mid-sized telescope, you can certainly see that shadow if the scene is good and if it's not cloudy or snowing or whatever. Jupiter's always a lovely object to see in a telescope. Even a small telescope will show its moons and two of its equatorial bands, and a larger telescope will just show you more detail, and even the great red spot, which isn't really red, it's more salmon colored. And Jupiter is blazing forth in the constellation of Pisces. It will be in our sky for the next few months. And moving on to Uranus. And it is a binocular or telescopic object, and it glows with a pale blue or even an aquamarine color. Now, it is possible to see Uranus with the naked eye from a very dark spot. I've never been able to see it, but maybe my eyes just aren't that good anymore. Which brings us to the star of December, the planet Mars. Mars reaches opposition on the night of the 7th. Some books say the 8th, but they're on Universal Time or Greenwich Mean Time. Mars is actually at opposition at 11 o'clock p.m. Mountain Standard Time. Even in a small telescope, you can make out some surface features on Mars. There was a dust storm on Mars earlier, but that seems to have settled down. So hopefully there will be no more storms kicking up, and we can watch Mars for the next few months with telescopes and see its features. Now, on the 7th, the day of opposition, there's also something else going on with Mars. Mars is going to be occulted by the moon, which also happens to be at opposition on the 7th, which means it is full. So there we go. There's the moon. There's Mars. If you remember back in 2003 when people were yapping about the Mars being as big as the moon, as you can see, that was just a lot of poppycock. So let's just run this simulation here. And I'm running it at 250 times speed. And there the moon is passing in front of Mars. Now, it starts to pass in front of Mars around 8:03, and it'll take a few seconds, maybe 20, 30 seconds for the moon to completely cover its disk. So let's keep this running. Just zoom out a bit here. And there it appears again at 9:04. So, we had an occultation of Uranus a couple months ago, and I tried to watch it, and it was an almost full moon, and it was just, the moon was just so bright, and Uranus is just so faint, I couldn't see it. But Mars is as bright as Jupiter right now. So you will be able to see the moon close in on Mars and then pass in front of it. So it takes about an hour for the moon to fully cross in front of the planet. So it's something to watch. Now, at the TELUS World of Science, weather permitting, of course, they're going to open up the observatory there, the RASC observatory. But because, from the point of view of our telescopes, they all point due south, basically. And Mars is going to be quite a bit in the east. And we have some trees in the way. And the city won't let us chop them down. We're going to have telescopes out on the walkway that will be able to view this event. So if you're around and the weather is cooperating, it's not cloudy and snowy and stuff like that, come on down to the TELUS World of Science and visit us at the RASC Observatory and watch the moon occult Mars, or just come there for the opposition of Mars, and after the moon passes, have some great views through some of our telescopes. And speaking of the moon, on December 1st, the moon is near Jupiter and also Neptune. On the 4th and 5th, it's near Uranus. And of course, we just talked about the occultation of Mars on the 7th. And on Boxing Day, it is near Saturn. And as we get on to the end of the year, it is near Neptune on the 28th and sliding past Jupiter on the 29th. We have a couple of meteor showers in December. The first one up is the Geminids, which occur morning of the 14th or evening of the 13th. There is a waning moon in the sky at the time, which is going to cut down on the amount of meteors you see. It's a fairly active shower. It can sometimes get between 50 and 120 meteors per hour from the Geminids. This is the radiant here. And the shower is caused by debris from asteroid 3200 Phaethon. It's one of the few showers that's caused by debris from an asteroid rather than a comet. And the other shower is the Ursids. And here's the radiant here. It is not an overly active shower. You can get between 5 and 10, sometimes even 15 meteors per hour. And it is caused by debris from comet 8P Tuttle. Both these showers are best visible after midnight. So dress warm, get away from the city, take a chair. You don't need binoculars, you don't need a telescope. You just need your eyes and enjoy the show. And hopefully we'll get good weather. On December 23rd, you can spot a 9th magnitude comet with binoculars or a small telescope placed conveniently close to Polaris. To find Polaris, find Ursa Major, the Big Dipper, follow the 2 pointer stars to the bright star Polaris. And this comet, ZTFC 2020 V2, is located only about 4 degrees away from Polaris. So It's ninth magnitude, so it should be visible in binoculars or a small telescope. And there it is. And you can watch it move from day to day. The winter solstice occurs on the 21st of December. The sun reaches its furthest point south on the globe at 3:48 p.m. Mountain Standard Time. On that morning, it rises at 8:48 a.m. here in Edmonton in the far southeast and sets in the far southwest at 4:15, giving us 7 hours and 27 minutes of daylight. And here is representation of the Earth in its path around the sun with two equinoxes, the spring and fall equinox, and then two solstices, the summer and the winter solstice. By 9 o'clock, the summer constellations have pretty much all left the scene in the south, and it is dominated by the winter constellations. We have Taurus, Orion, Gemini, Pisces. But really, it's these three guys here, Orion, Taurus, and Gemini, that are really the stars of the winter sky, in my opinion. And these are some of the sights you can see in these three constellations here. I talked a lot about them in the last couple months, so I'm not going to go into it again, except because of the month. Let's look at the Christmas tree cluster, NGC 2244, or 2264, sorry, just to celebrate the season. So that's about all I've got for December, and we will move on to other sections. And if there's any questions, now's the time to ask. Thanks. Okay, are there any questions? All right, we will move on to the moon.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path every month of the year. After 7 days, the
first quarter was yesterday, the 29th of November. So let's go to the full moon, which will be on December the 7th. It's also the same day that Mars is at opposition. And the December full moon is known as the cold moon. It's also known as the long night moon, the oak moon, I don't know why, oak, the snow moon, or the winter maker moon. Third quarter is on December the 16th. The moon is new on the 23rd. And first quarter rolls around right at the end of the year on December the 29th. Now, this is where I talk about a feature on the moon. Now, originally we talked about rolling in the what Alistair was doing with the introduction to sky gazing, but that's not going to happen. Alistair stepping away. Berta just says she can't do it. And so what I'm going to be doing, starting officially next month, is I'm going to use the Explore the Universe certificate program to pick features on the moon and for constellations. But for now, I'm still going to use the Explore the Moon certificate program for this feature. And the feature this month is the crater Cleomedes. And this is a picture of mine I took through my telescope, and there it is there. It's just above the Sea of Crisis, or Mare Crisium. And this is just a blow up of that picture. There is the crater there. And this is just a better picture taken by someone who's better at astrophotography than I am. So it is a large impact crater, and it's immediately north of Mare Crisium. It's 126 kilometers across, 2.7 kilometers deep, and it's an old crater with a very badly worn rim. This is a picture taken from the Lunar Reconnaissance Orbiter, and you can see the rim is quite old, and it has a few secondary impact craters along its edge and within the crater itself. It's an easy target for binoculars, and it looks great in a small telescope. It starts to become visible about 3 days after the new moon. It was named after the Greek astronomer Cleomedes, who is known mostly for a book he wrote called On the Circular Motions of Celestial Bodies. When he lived isn't really known for sure, but some historians think it was in the 4th century AD. So there it is, Cleomedes, and easily seen in binoculars. Okay. The constellation I'm doing tonight, I took from the Explore the Universe book because it is a winter constellation. I did this not that long. I did it about a year ago, but I'm doing it again. So I'm doing Taurus the Bull, and this is the star pattern. And there's the astronomical drawing. There's Taurus right there. And there's a illustration of what the ancients thought they were looking at when they saw Taurus the Bull. It's a large constellation. It's visible in the evening sky, right, starting in autumn, actually. Very, very visible through the winter and well into spring. And currently Mars is within the confines of this constellation. So if you go outside when it's clear, it's not clear right now, it's snowing, and spot a very bright orange star there, that's the planet Mars. And I took this date of the 15th, and Mars is right there, just if you're interested. And Orion pursues the bull through the sky, through the winter sky. Orion's right there, the hunter, and he's always trying to catch the bull, but he never catches it. The astronomer Jack Horkheimer, who used to host a segment on PBS back in the 80s, used to say when Taurus is rising, and particularly the Pleiades, which is up here, and I'll talk about that a little later, when he would see the Pleiades, it reminded him of smoke from burning leaves in the fall. So the story of Taurus is, in Greek mythology, is that Zeus changed himself into a beautiful white bull to win the affections of a Phoenician princess, Europa. After Europa hopped onto the bull's back, the bull swam across the Mediterranean, taking Europa all the way back to the island of Crete. There's another story about Zeus hiding his girlfriend from his wife. He happened to do that a lot by changing the girlfriend into the form of a heifer or bull. And I'll just mention a little bit of astrology. The horoscope says if you're born between April 20th and May 20th, you're a Taurus, but actually that's not true. The sun is in the constellation Taurus between May 13th and June 21st. So if you think you're a Taurus, you're probably not. There are two fine open clusters in Taurus. The first one is the Hyades right there. And the next one is the Pleiades. The Hyades are the nearest open cluster of stars to Earth. They're only about 153 light years away. It forms a distinctive V shape, even to the naked eye. The brightest stars form this V, and it marks the head of Taurus the bull. And it is, let's flip my page here. The cluster actually, through binoculars, you can see dozens and dozens of stars in the cluster, and through a telescope, you can see hundreds of stars. The whole cluster is, they've determined that it is spherical in shape and they share a common origin. So they all were born around the same time, about 650 million years ago. And they all share the same motion through the space and the same chemical composition. The Pleiades, up here, is another open cluster, and it is like the Hyades. It's very young. It's only about 100 million light year or 100 million years old, and it's about 400 light years away. And it contains many hot white stars. Naked eye, you can see 6 of them. In binoculars, you can see dozens. And even in a medium telescope, you can see hundreds of stars in the Pleiades. There's a close-up view, and you can see some of the nebulosity left over from the nebula where these stars formed originally. It may contain 1,000 stars within the cluster. There's another picture. In Greek mythology, the Hyades were 5 daughters of Atlas and half-sisters to the Pleiades, and after the death of their brother Hyas, the weeping sisters were transformed into a cluster of stars that were afterwards associated with rain. The Pleiades, also daughters of Atlas, after Atlas was forced to carry the heavens on his shoulder, Orion began to pursue the Pleiades, and Zeus transformed them first into doves and then into stars, and set them into the sky. And Orion is said to still pursue them across the night sky, along with the bull. And an interesting thing about the Pleiades, in Japan, that cluster is known as Subaru, and that cluster, the 6 bright stars in that cluster form the logo for Subaru automobiles. Okay, so this is space history, and this is where we look at a past event that's not only occurred in this month, but whose anniversary year is divisible by 5. So in 2022, for the last time this year, we'll be looking at something whose years ends in 2 or 7. And I picked a big one for this once, and they'll probably be in the news next later on in the month. And that is Apollo 17, the final Apollo mission. This is the crest of the Apollo 17 mission, named the crew below it. It contains an image of Apollo, the American Eagle, the 3 stars representing the 3 astronauts, the moon, and then Saturn, and a galaxy representing destinations for the future. There were 6 Apollo landings on the moon. These are the locations of the 6, starting with Apollo 11, and 12 and 14, 15 up in the Apennine Mountains, 16 in the Descartes region, and then Apollo 17 in the Valley of Taurus Littoral. And this is where they were headed. The Valley of Taurus Littoral is located on the southeastern edge of the Sea of Serenity, and it is surrounded by a ring of mountains formed between 3.8 and 3.9 billion years ago when a large planetesimal impacted the moon and formed the Serenitous Basin. It was picked because it was anticipated to have samples of both highland and Maria material, and even material of volcanic origin. The crew was Commander Eugene Cernan. That's him on the right of your picture. You can always tell the commander because he has these red stripes on his arms and legs. And when he's out on the moon, he has a red stripe on his helmet as well. On the left is Harrison Jack Schmitt. He was the first and so far only scientist to fly to the moon. He was picked with a group of astronauts, all scientists, all civilians, where all the other astronauts were all military test pilots. He was the only one who flew on the Apollo missions to the moon, although some of the other scientists flew in the Skylab program, and some even stuck around to fly with the shuttle. And then in the middle is Ron Evans. He is the command module pilot. He would stay in orbit in the command module while Schmitt and Cernan made their way down to the moon. Schmitt is the only one that's still alive right now. The command module call sign was America. The lunar module's call sign was Challenger. And they only used those call signs when the two spacecraft were separated. When they were joined together, it was always just 17 or Apollo 17. The crew trained extensively, not only at NASA facilities, but also went on geology field trips. Schmitt, as a professional geologist, was involved with training of all the previous crews. The crews of the last 3 missions had the equivalent of a master's degree in field geology. This was what NASA referred to as a J mission. The last 3, 15, 16, and 17, were all J missions, which meant the LEM was outfitted for an extended stay on the moon and carried the lunar roving vehicle, or the lunar rover, or just simply the rover. And here you can see that is the actual lunar module behind them, still getting outfitted. They haven't put the legs on it yet. And this is the actual rover which they took on the moon. And you'll notice that it's actually, the wheels aren't touching the ground. And that's because the rover was designed to function on the moon. And if it was sitting on the moon in 1G and the astronauts got in it, it would collapse. It could not support itself and its passengers in the 1G environment. So after nearly a 3-hour delay, due to a hardware problem, the third stage pressurization didn't go as planned. So the automatic sequencer shut the countdown down at T-minus 30 seconds. But after almost 3 hours, they fixed the problem, and Apollo 17 lifted off at 12:33 a.m. or 10:33 p.m. on 12:33 on December 7th or 10:33 on December 6th. And it was the first nighttime launch of an American crewed spacecraft. And what I'm told, it was quite spectacular. On the way out to the moon, they took this full Earth picture, which is seen, continues to be seen. It's a very famous picture because it was December. You'll note that the southern hemisphere is pointed toward the sun, and Antarctica is fully in sunlight. And we up in the northern hemisphere were in winter. The spacecraft went into orbit around the moon on December the 10th. And on December the 11th, the two Schmitt and Cernan got into the lunar module Challenger and separated from the command module America and made one orbit over the landing site. And this is the view out the lunar module window of their destination. They would be landing right in this valley. And that view is from 50,000 feet. So Cernan landed Challenger on December 11th, only 200 meters from the original landing spot. And about 4 hours later, the astronauts began the first of 3 EVAs on the surface. The first order of business was to unstow the lunar rover and outfit it. And then they spent the balance of the EVA setting up the Apollo Lunar Surface Experiment Package, or ALSEP. And that's a picture of it sitting there, and the rover you can see sitting in the background, and you can see one of the mountains that ring the valley in the background. Although that mountain looks like a small hill and is quite close, because there is no atmosphere on the moon to give anything a sense of distance. Everything looks really close, but it's not. It's actually several miles away, and that mountain is several thousand feet tall. And also, they would set up the American flag. And here's a picture of Cernan standing next to the flag with the Earth in the background. Now, during the first EVA, Cernan accidentally caught his hammer on the right rear fender of the rover and broke it off. This caused all sorts of problems with dust being thrown up by the tire, which would come over and cover the astronauts and also cover the equipment on the rover. Now, the dust coating the equipment and the spacesuits could lead to overheating. They came up with a fix at Mission Control using maps, clamps, and duct tape to make a fix for the fender, and that fix actually held for the balance of the mission. On the second EVA, the astronauts went about 7.6 kilometers from the Challenger, and that's the farthest distance of any Apollo mission. On that second EVA, they drove a total of 20.4 kilometers and made 4 stops where they collected samples. On the second EVA, which was probably the most exciting part for the astronauts and for folks at home and the scientists in the back room, they came across orange soil at one of the stops near a crater called Shorty. And you can kind of make it out in this picture. And there, a bit of hint of orange in an otherwise gray landscape. Schmidt was very excited about it, and he speculated the soil may have been oxidized. However, it turned out what that orange soil was very small beads of volcanic glass that formed over 3.5 billion years ago. Some scientists in Mission Control felt the astronauts may have discovered a volcanic vent. However, analysis, once they got home, realized that Shorty, the crater where the soil was found, was not volcanic in origin. It was a plain impact crater. But the orange soil had formed a long time before that crater was even formed by a fire fountain that sprayed molten lava out onto the lunar surface. And the orange soil got buried in subsequent eons as it had formed 3.5 billion years ago. And it became exposed when the impact that formed Shorty less than 20 million years ago exposed it. It was an exciting find. Cernan took a sample during EVA2 that was maintained in a vacuum until better techniques became available. He joked with Houston about placing a note inside, and the container remained unopened until this year, until 2022. He got the sample from underneath a rock, so it was one that hadn't been exposed to sunlight or any other impacts. Now, I don't know if any of you guys ever watch our regular meetings, but I did a News from Space. It was a video series I did for the June 2022 meeting where I actually talked about this sample. The second EVA was the longest of the mission. It was 7 hours, 36 minutes. The third and final EVA began on the 13th, and it lasted a little over 7 hours and made 4 stops and drove 12 kilometers, including climbing 80 meters above the plane on a 20-degree slope. At the end of the EVA, Cernan and Schmidt displayed a rock that would be broken up and distributed around the world, and unveiled a plaque on Challenger's front leg, marking the end of Apollo. Then, as Jack Schmidt prepared the samples to transfer to the LEM, Gene Cernan took the lunar rover and parked it for the last time, a couple hundred meters from the LEM, so its TV camera, which was remotely controlled, could watch them leave the moon the next day. Snapped a few more photos, and then made his way up the ladder and ended the first exploration of the moon. And Gene's final words on leaving the moon were this.
This is Gene, and I'm on the surface. And as I take man's last step from the surface, back home for some time to come, but we believe not too long into the future, I'd like to just let what I believe history will record, that American challenge of today has forged man's destiny of tomorrow. And as we leave the moon in Taurus Littrow, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. Godspeed the crew of Apollo 17.
And once back inside the LEM, they discarded any equipment that they did not need anymore. You can see in this picture here, that's one of their backpacks that they tossed out the door. Any waste that had accumulated, and got ready for liftoff on the 14th. Cernan and Schmidt said 3 days on the moon. They made 3 EVAs, total of 22 hours out on the lunar surface, and they traveled 36 kilometers in their EVAs on the lunar rover and by foot, and they returned 115 kilograms of samples. And here you can see the spacesuits and helmets stacked up in the back of the lunar module, and you can see how dirty they got. They got really, really, really filthy on this mission. Now, Ron Evans up in orbit for those 3 days, he was busy also. He had a suite of instruments and cameras in what they called the Scientific Instrument Bay, or the SIM Bay, a Scientific Instrument and Mapping Bay, I should say, SIM Bay, and you can see it there. So he was taking measurements, taking pictures, trying to detect any sort of a magnetic field, all sorts of stuff. He wasn't just up there floating around doing nothing. He was quite busy. And of course, this is before digital, so he had to get the film from the SIM Bay. And so on the 17th, he made his way back to the SIM Bay and made a deep space EVA. You can see he's got the film, one of the film packs attached to him there, so it doesn't float away. Now, on the way back, Nixon, President Nixon, sent a congratulatory message to the crew. And I'll read a bit of it. I'm not going to read the whole thing, but as the Challenger leaves the surface of the moon, we are conscious not only of what we leave behind, but what lies before us. The dreams that draw humanity forward seem always to be redeemed if we believe in them strongly enough and pursue them with diligence and courage. Now, the beginning of the second paragraph to this statement really made the astronauts see red, especially Jack Schmidt. He was pretty upset when Nixon wrote, "This may be the last time in this century that men will walk on the moon." And that really upset the astronauts. But space exploration will continue. The benefits of space exploration will continue. The search for knowledge through the exploration of space will continue, and there will be new dreams to pursue based upon what we have learned. Splashdown of the mission was on the 19th. It's a normal splashdown, and they were picked up by the aircraft carrier USS Ticonderoga. Now, that phrase, this may be the last time in this century that men will walk on the moon. I remember hearing that at that time, and I was really surprised that that was said. So what was lost by the end of Apollo? Well, I'll throw a couple things here. This is the EVA map from Apollo 11. And they explored an area slightly larger than a baseball infield. So you can see the LEM right here. They set up their equipment or their experiments. The seismometer and the lunar range reflector are about near first base. They never really got up as far as third base. Armstrong did make a brief trek out into the middle of center field to look in a crater and take some pictures, but they didn't really go very far. They hardly went anywhere on Apollo 11. They were just strictly working around the lunar module. Apollo 17. This is the map of their exploration. The first EVA, they didn't go very far because they spent most of their time setting up the ALSEP. They did make one stop there. The second EVA, they drove the record, 20 kilometers all over, and then the third EVA, they went over into the North Massif, and they explored quite a bit and made quite a few stops. And the great thing about the Apollo era was you could watch them do it, and the pictures just got better. This is a frame grab of a Apollo 11 TV transmission with a black and white camera mounted on a tripod with a 10 frame per second scan rate and poor resolution. The normal scan rate of TV back then was 30 frames per second. Time Apollo 17 came along, you had a full color remote controlled camera, and they also were enhancing the picture back on the ground in real time. So this is my little rant. 4 years earlier, humans orbited the moon for the very first time. And in that time, 9 missions flew to the moon and 6 landed on its surface. And in the 50 years since humans visited the moon, we've sent one vessel capable of carrying humans out to the moon, and it's uncrewed. And that's orbiting the moon right now as we speak. All the large infrastructure in place at the time of Apollo was dismantled to make way for the shuttle. The launch pads were converted for shuttle. The VAB, where they assembled the Saturn V, was switched over to shuttle, and now it's switched over to Artemis. So I grew up with Apollo. And 10 years ago, I was at a symposium at the U of A with a few of our other members, and we were taking questions from the audience. And I was asked, what surprised me most about the space program? And I said, it's that we haven't ventured outside a low Earth orbit in 40 years. So this was 10 years ago. Gemini 11, which flew in 1966, flew higher than any shuttle mission, any of the 130 some odd shuttle missions that flew in the 80s, 90s, and early 2000s. And Gemini 11, if the full spacecraft was there, I could put it in my garage. It wasn't very big. I've seen the reentry capsule or portion of Gemini 11. It's not very big, and this thing flew higher than any shuttle flight. It flew at the passed into the Van Allen radiation belts. It was quite high. It held the record for highest flight above the Earth until Apollo 8, which flew to the moon. Parts of 2001: A Space Odyssey, which I first saw in 1968, I thought, well, this is possible. But I think the only thing that we ever got anything shown in 2001 that we have now are video phones and a zero gravity toilet. I wasn't really thinking about that. I was thinking about, bases on the moon and stuff like that, because, we went from a standing start, the Americans went from a standing start with a 15-minute space flight to landing on the moon in a little over 8 years. So this is the Apollo 17 landing site as viewed from the Lunar Reconnaissance Orbiter. And you can see there's the base of the Challenger there. There's the ALSEP is over here. And the SEP stands for Seismic Experiment Package. And what that was is they would leave basically a mortar with explosives in it, and they would set that off after the astronauts had left the moon, and take seismic readings, not only by the seismometer with the ALSEP at Apollo 17, but all the other ALSEPs that were left by previous missions. I'm almost done here. And people ask me, when did you get so interested in space and astronomy? And I'll say, I've always been interested in space and astronomy since I was a kid. And back in 1972, back 50 years ago, we didn't have VCRs, we didn't have PVRs, there was no DVDs. So for Apollo 17, I took my movie camera, because I also like to make stop motion movies, and I filmed parts of the mission off the television. Now, none of my projectors work, but my editor still works. So I set it up and filmed a little bit off my editor. So the picture is really crappy, but not only did I film it, but I also recorded it with my cassette recorder. So I've got a little recording of stuff I recorded off the TV 50 years ago. And in this little clip, you'll actually hear the camera come on and run. So just to say, hey, I'm a big nerd.
One of the astronauts hopping across, the camera on the lunar roving vehicle is some 300 feet from the lunar module, as we've noted. It is controlled from the ground and panned around, now showing one of the...
Okay, so enough of that. So finally, before we end this, I know we've gone a little long. I did put together a small little Apollo 17 highlight reel. It's full of mostly mostly stuff you don't normally see.
Ignition sequence started. All engines are started. We have ignition 2, 1, 0. We have a liftoff. We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center as the Saturn V is moving off the pad. It has now cleared the tower.
Y'all complete. We're in the roll, Bob.
Roger, Gino. Looking great. Thrust good on all 5 engines.
Okay, babe, it's looking good. Your roll is complete. We are pitching. I'll give it to you. There it is. Proceeded. And there it is, Houston. There's Camelot. Wide on target. I see it. We got them all. 42 degrees, 37 degrees, through 5,500. 38 degrees.
Challenger, your go for landing.
42 degrees through 4,000. 47 now. 47 degrees through 3,500. 49 degrees. Very little dust. Very little dust. 40 feet, going down at 3. Stand by for touchdown. Stand by. 25 feet, down at 2. Feels good. 20 feet. Going down at 2. 10 feet. 10 feet. Contact. Stop, push. Engine stop. Engine arm. Proceed. Command override off. Boat control ahead. Hold. Pings auto. Okay, Houston, the Challenger has landed. Okay. We landed in a very shallow depression. why we've got a slight pitch up angle. Very shallow. Dinner plate like this crater just about the width of the straddle.
17, we have a picture.
Yep. Oh, beautiful, babe. It's all yours. I hope it moves now.
It does.
I hope it moves. You'll find out. Hey, it moves. It's alive.
And,
Okay, Bob, I'm going to get SRC-1.
okay.
Green is over the port.
Copy
I'm
that.
going to move one big rock. What am I doing down in here? What were you doing down in there? Okay. And Bob, there's a little bit of dust adhering to the sides of the LMS. And a few particles, less than 0.5% of the surface on the top. But of course you're going to clean that one. Hope not. Oh, we is in trouble. I got me going the wrong way. I did. I went to min instead of max. Here it comes. Oh, boy. Oh, boy. Man. Watch it. Okay, Jack. You're all right. Still deployed. Huh? Still deploying. Nothing. You're all right. It's coming out a little hard. I'll do that. Oh, that's all right. Feel like it's loosening up at all? Yeah. Oh, excuse me. Yeah, go ahead. Okay. 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 Stay there. Stay there. Okay, back. Thank you. Hello, my UHD, among other things. Bob, that's almost full of samples, and I think that big rock would be, probably wouldn't fit in there.
Okay, then we'll put that in the big bag.
No rover samples. Sorry. Okay, hold it right there. Let me get the, okay. Let me move it up just a little bit. Right there. Okay, hold it right there. Let me see how much room I got coming up. I want to turn this around. We tape that other end, Jack. There you go. It's tending to fold a little bit. I think, yeah, but the dust will be coming up from under it. Let's see. Temperature, I think, is making it fold. Oh, that'll give us plenty of room down there. That's, yeah, I just don't want to interfere with that steering. You think that'll stop the dust that way? Well, it'll stop some of it if it stays on. Well, but I mean, it's not projecting outward at all. It's curling back under. Well, when I put a clamp here and a clamp here, see what'll happen? Oh, okay. Is that about where you want it? Now I got to clamp it right in that rail. There's not much to clamp it on the inside. No. Keep the knob up. Yeah, you got it. Hold it right there. We got enough overlap on this side. Can I change your oil?
Thank you, Gino. It looks much better.
How about any other service I can be?
Copy that, Jack.
Okay, I think I got it. I think I got it, Bob.
Okay.
Boy, another exercise in dexterity. Okay, the LMB has gone to, oh, hey! Wait a minute. What? Where are the reflections? I've been fooled once. There is orange soil. Well, don't move it till I see it. It's all over. Orange! I'll hold it until I see it. I've stirred it up with my feet. Hey, it is! I can see it from here. It's orange. Wait a minute, let me put my visor up. It's still orange. Sure it is. Crazy. Orange. I've got to dig a trench, Houston.
Copy that. I guess we better work
out
fast.
of his wits. It really is. Fantastic, sports fans. It's trench time. You can see this in your color television, I'll bet you. How can there be orange soil on the moon? Jack, that is really orange. It's been oxidized. Go around and get the lunar sounder over here. It looks just like an oxidized desert soil. That's exactly right. Okay, got your bag?
Okay, we got 12 or 13 minutes left of the station unless you take that extra 10 minutes that we were offering you.
Let's take it, Bob. We got to get the rake. Let's take it. We'll need it. Let me try again. Okay. I don't know whether I can or not. You know how far under you're getting by any chance? Yeah, I got under an east-west overhang about 20 centimeters, way back. Quite a ways out. It goes even farther, but that's about as far as I can reach back in the sample. It's enough, Jack, for me.
Okay, I copy that.
That's in back 500.
And 17, if you want to just take a minute, you might look up in the sky and notice that our camera's taking a beautiful picture of Mother Earth.
To commemorate, not just Apollo 17's visit to the Valley of Taurus Littrow, but as an everlasting commemoration of what the real meaning of Apollo is to the world, we'd like to uncover a plaque that has been on the leg of our spacecraft that we have climbed down many times over the last 3 days. And I'll read what that plaque says to you. First of all, it has a picture of the world, two pictures, one of the North America and one of South America. The other covers the other half of the world, including Africa, Asia, Europe, Australia, covers the North Pole and the South Pole. In between these two hemispheres, we have a pictorial view of the moon, a pictorial view of where all the Apollo landings have been made. So then when this plaque is seen again by others who come, they will know where it all started. The words, "Our here man completed his first exploration of the moon, December 1972 AD. May the spirit of peace in which we came be reflected in the lives of all mankind." 99, proceeded, 3, 2, 1, ignition. Right away, Houston. Bets are good. Ag thought. Pitch over.
Roger, you have good thrust.
Okay, 30 seconds. 308 your number. Okay, coming through 1,500 feet, and H-dot looks good.
Roger, we've lost data right now, but we'd like aft Omni, please.
Okay, come up on 40 seconds in. We're going. Coming right over top of Camelot.
Challenger,
Challenger,
Houston, your
go.
go
We're
at
coming
2
through
minutes. We'd like ag
14K.
smoke control auto. Over.
Okay, you watch the table, Gino. I'm watching it. Just get calm as you can.
That's affirmative.
Okay.
Outstanding quality picture, Ron.
See me wave?
That's affirmative.
Okay. Beautiful. Yeah, well, it looks just like the side almost. It's more blistered on the side than it is on the bottom, but I think maybe it's just the paint. Yeah, I'm coming back in. Oh, okay. Pretty much it.
Module is descending. Stand by for splashdown. America's at 300 feet. Splash. What? Recovery, America, stable water, and the crew is gone. Great deal of cheering going on here in the control center as the splashdown was watched in real time from the recovery helicopter. And mark the time at 3:04:31 ground elapsed time. The command module is stable one. The sea state is mild, and the three-man parachutes are arrayed around the command module at approximately 120 degrees apart.
Heavens Above is a great source of all things astronomical. You can print star charts for your exact geographic location. You just have to enter in the coordinates. And you can check on comets, satellite passes, etc. The next What's Up will be on Wednesday, January 4th, 2023, brand new year. The next meeting of the RASC Edmonton Center will be on December the 12th, and that is live in the Ziegler Stardome inside the TELUS World of Science, or on Zoom. There will be a link on our website. And these are both at 7:30 p.m. Mountain Standard Time. And considering the season, a special guest appearance right now. Are there any questions? Oh, I see a couple chats here. Let's see what they have to say. And I don't see anything in the chat. Great. Bring back news. Oh, bring back news from space. You know, I don't know how many people have told me that. I may have special editions of that, but it is a lot of work. And anyway, anything else? You can unmute yourself if you wish.
Did Apollo 17 splash down near Cuba?
No.
They were all smoking cigars. So
Oh, yeah, no, that was a tradition. They would always smoke cigars at the end of the meeting, or at the end of the mission. It splashed down in the Pacific. Yeah, that's funny, actually. Yeah. I notice in some movies like The Right Stuff and that they break out the cigar as soon as they launch something, but no, they always waited till the end to break out the cigars. All right. If there's nothing else, I will be cleaning this up and posting it on YouTube probably tomorrow or Friday. And you know, if you missed anything or something dropped out in the middle, but I'll say thank you all for joining me today. Stay warm. Have a great holiday season, whatever you celebrate, or if you celebrate. And we'll see you in the new year. And clear skies, everybody. And don't forget to get out and see Mars. And that occultation, hopefully the weather will be good that night. So with that, I will say good night.
thanks, Jeff.
Thank you.